Hello and welcome to my channel. In this video we are going to solve exam questions on algebraic expressions from International Advanced Level Pure Mathematics 1 WMA1101 from May-October 2020 question papers till June 2022. This is part 2. In part 1 I have covered the questions from specimen 2018 to January 2020. I have attached the link of the part 1 along with this video in the description box, so you can click on it and you can go through rest of the exam questions. Now let us come to the part 2. Here the question given is, given that 3pq square whole raised to the power of 4 times 2p square root of q to the power of 8 is equivalent to a p raised to b and q raised to c. Find the values of the constants a, b and c. So we are going to use the laws of indices to solve this example. You can click on the link where I have explained the laws of indices and all the rules which we will be using over here. So let us quickly start with this question. Here for the first term, let me write it as 3p q to the power of 2 raised to 4. So over here we have to distribute this 4 to 3, to p and to q independently. So it becomes 3 to the power of 4 times p to the power of 4 times q square to the power of 4. This is by using the laws of indices. Now 3 to the power of 4 is 81 and p to the power of 4 remains the same, and here q to the power of, again using laws of indices, the powers get multiplied. So 2 times 4 is 8. So we have got the solution for this bracket. Now let me solve the next one, that is 2p and square root of q to the power of 8. Now 2p I will write it the same way because it is in the most simplified form, and square root, I'm going to change the square root to a fractional power and I will write it as 1 over 2. Again using the laws of indices where any radical can be changed to a fractional power. So let me further solve this. So 2p remains the same and again the powers of q will get multiplied. So 8 times half, let me write it 8 times half. As you can see, if there is multiplication, 2 cancels 8 and we are left with 2p q to the power of 4. Now let me combine these two answers which I got for independent terms, and you can see there is a multiplication between the terms. So I'm going to multiply this answer with this answer and let's see what we get. So it is 81 p to the power of 4 q to the power of 8 times 2 p q to the power of 4. Now here we are going to multiply the numbers first. So 81 times 2 gives us 162 and p to the power of 4 times p to the power of 1. So whenever there is a multiplication and the bases are same, then we have to add the powers. So it becomes p to the power of 4 plus 1, which is 5. Similarly for the q term now, since there is multiplication between the q terms and the bases are same, which is q and q, we are going to add the powers. So 8 plus 4 is 12. So this is the most simplified answer we have got for the given example. Now they have said that this is equivalent to a p to the power of b and q to the power of c. So let us compare it and check what we will get. This is a p to the power of b and q to the power of c. As you can see, a is a constant over here. So we get a as 162 and we are going to compare the p terms now. As you can see, in place of b we have 5. So we have got the value of b as 5. And finally for the q, In place of c we have 12. We are going to compare it. So we got c is equal to 12. So this is the answer for the given question. So find the values of constants a, b and c. We have got the value of a, b and c. Now let us look at the next question on algebraic expression from International Advanced Level, Pure Mathematics 1, January 2022 question paper. Surprisingly, there were no questions on algebraic expression in the entire 2021 question papers. So you can see directly from 2020 I have moved on to January 2022. So let us quickly start with this example now. In this question, you must show all stages of your working, and solutions relying on calculator technology are not acceptable. That means we have to show them all the steps thoroughly. So let us start with the first one. You can see they have given an expression over here, and they want us to express the f of x in the form ax square plus bx root 2 plus c, where a, b and c integers to be found. This question can come also under the quadratic chapter, that is chapter 2 from Pure Mathematics 1. But here we can relate it to algebraic expressions as well, because you can see there is a radical involved. So they want us to get it in this form. So the first thing we can do is, let me take the first bracket of f of x. So I will write it as x plus root 2 the whole square. So I can expand it into two brackets and write it as x plus root 2 times x plus root 2. So I have written the square and I have split it into two terms. Now expanding it further, that is expanding the brackets, we get x times x as x square, and x times plus root 2 gives us plus root 2 x plus root 2 times x gives us again root 2x plus root 2 times root 2 gives us 2. Now let us just further simplify this and combine the like terms. So x square stays the same, but root 2x and root 2x are like terms, so we can just add them and write it as 2 root 2x plus 2. So this is the expansion of the first bracket. Now let us expand the second bracket, which is 3x minus 5 root 8 whole squared. So it is 3x minus 5 root 8 the whole square. Again I am going to split it up into two brackets, that is the first bracket is 3x minus 5 root 8, and this is multiplied with 3x minus 5 root 8. So here again I am going to expand the brackets and distribute the terms. 3x times 3x gives us 9x square. So 3x times minus 5 root 8, let us see how much we get. So we'll take only the numbers. 3 times in the bracket minus 5 root 8. So close the bracket. We get it as minus 30 root 2. So we will write here as minus 30 root 2. And this is minus 5 root 8 times 3. Again it's the same term as we had multiplied this. So again it turns out to be minus 30 root 2. I forgot to write x here. So yes, here also there is an x term. Now minus 5 root 8 times minus 5 root 8. So let us check how much we get. Minus 5 root 8 multiplied with minus 5 root 8. So here we get it as plus 200. So let us write here as plus 200. Now further simplifying this and combining the like terms, we get it as 9x square and minus 30 root 2 minus 30 root 2. When we combine this, we get it as minus 60 root 2 x plus 200. So these are the two answers of these two brackets. Now let us see what is the operation between the two terms. There is an addition between the two terms. So I am going to add the answer of the first bracket with the second answer. So here we have x plus root 2 the whole square plus 3x minus 5 root 8 the whole square is equal to, let me start adding the terms, x square plus 2 root 2 x plus 2 plus 9x square minus 60 root 2 x plus 200. Now we have to just simply gather the like terms. We can see x square plus 9x square, that gives us 10x square. And now we are going to gather the like terms, that is x term and x term. This is plus 2 root 2 and this is minus 60 root 2. So we can check it over here also, plus 2 root 2 and minus 60 root 2. So we get it as minus 58 root 2. So we have minus 58 root 2 x, and again we have plus 2 and plus 200. So we have it as plus 202. So this is the answer we get, and let us check now what they want us to do. We have to express f of x in the form ax square plus bx root 2 plus c, where a, b, c are the integers to be found. So let us compare now with the given format. So we have here ax square and they have given it as plus bx root 2 and plus c. So by comparison, you can see here in place of a we have 10 and in place of b we have negative 58 and in place of c we have 202. So we have got the values of a, b and c by comparison. So this is how we solve the given example. Now let us look at the second part of the question. Solve the equation root 3 times 4y minus 3 root 3 is equal to 5y plus root 3, giving your answers in the form p plus q root 3, where p and q are simplified fractions to be found. So the first thing we can think about is expanding this bracket. So root 3 times 4y, we get it as 4 root 3y, and then we are going to multiply root 3 with minus 3 root 3. So let us check how much we get. So root 3 minus 3 root 3. So we get it as minus 9. So we have here as minus 9 is equal to 5y plus root 3. Now we will try to gather the like terms on one side of the equation and rest of the terms on the other side. So we can see that there are two y terms in the equation. So we can take minus 5 on the other side of the equation and write it as 4 root 3y minus 5y equals, and we'll take minus 9 on the other side. So it becomes root 3. So minus 9 becomes plus 9. Once we have done this, we will try to factorize the given equation by taking the y common from this term. So we have y inside the bracket 4 root 3 minus 5 is equal to root 3 plus 9. By taking the 4 root 3 minus 5 on the other side, we get it as y equals root 3 plus 9 divided by 4 root 3 minus 5. So we have to rationalize the denominator and get rid of the radicals in the denominator. So to do that, we are going to multiply and divide the answer we have got by the conjugate of the denominator. So we can write it as 4 root 3 plus 5 over 4 root 3 plus 5. This is called as rationalization. Now we will multiply the terms in the numerator. So root 3 multiplied with 4 root 3, we get it as 12. You can always use a calculator to calculate the terms. And then root 3 multiplies with 5, so we get it as 5 root 3. Then plus 9 multiplies with 4 root 3, so we get it as plus 36 root 3. And plus 9 multiplies with plus 5, giving us plus 45. So this is what we get at the numerator. Now let us look what we get at the denominator. So 4 root 3 multiplies with 4 root 3, we get it as 48. And 4 root 3 multiplies with 5, so we get it as plus 20 root 3. And minus 5 times 4 root 3, we get it as minus 20 root 3. And minus 5 times plus 5, we get it as minus 25. Now simplifying this, in the numerator we have 12 plus 45, which are like terms. So when we add them, we get it as 57 plus 5 root 3 plus 36 root 3 are like terms. So we get it as 41 root 3. Now in the denominator, we can see that plus 20 root 3 and minus 20 root 3 gets cancelled. So we are left with 48 minus 25. Let us check how much we get. 48 minus 25, we get it as 23. So we have here as 23. Now this is the most simplified form which we have got, and you can see we cannot simplify it further. So now we'll check with the format they want us to find out. That should mean p plus q root 3, and p and q are simplified fractions. So one more step we can add over here is we can just split out the numerators and write it as 57 over 23. So denominator is going to each numerator, plus 41 root 3 over 23. So if you compare it with p plus q root 3, you can see that we have p here as 57 over 23 and we get q as 41 over 23, and these are the most simplified fractions. This is how we solve the given expression. Now let us look at the question from International Advanced Level Pure Mathematics 1, June 2022 question paper. In this question, you must show all stages of your working. Solutions relying on calculator technology are not acceptable. Show that radical 180 minus radical 80 divided by radical 5 is an integer and find its value. So let us start by first finding out how much is radical 180. So let us see how much we get. So square root of 180 is equal to 6 radical 5. Make sure that your calculator is showing the answers in terms of radicals. So here we get it as 6 radical 5. Any answers in terms of decimals will not be accepted in this case. Now let us look at how much is radical 80. So here in the calculator it is square root of 80 is equal to 4 radical 5. So once we get these values, we are going to substitute in this given expression. So here we can write it as 6 radical 5 in place of radical 180 minus 4 radical 5 in place of radical 80 divided by radical 5. Now after this, we can factorize this expression and take the radical 5 common out of this term. So it becomes 6 minus 4 over radical 5. So once we take the radical 5 common out, we can see we can cancel it off, they divide each other, and we are left with 6 minus 4, which gives us 2. And in the question they have mentioned that we should be getting an integer and we had to find its value. So the integer is 2. So this is how we solve the expressions, and make sure that the answer comes in terms of radicals. Do not write the answers in terms of decimals. Now let us look at the second part of this question. Simplify 4 radical 5 minus 5 over 7 minus 3 radical 5, giving your answer in the form a plus b radical 5, where a and b are rational numbers. So here we have to again go for rationalization of the denominator. So let me write the numerator first. 4 radical 5 minus 5 over 7 minus 3 radical 5. Now I am going to rationalize the denominator by multiplying and dividing it by its conjugate. So 7 plus 3 radical 5 over 7 plus 3 radical 5. Next I am going to multiply the numerators first by expanding the brackets. So we have 4 radical 5 times 7, that gives us 28 radical 5, and 4 radical 5 times 3 radical 5 gives us 12 times 5 is 60, and next minus 5 times 7 gives us minus 35, and minus 5 times 3 radical 5 gives us minus 15 radical 5. You can use the calculator to multiply the terms. Then coming to the denominator, we have 7 multiplied with 7, we have 49. 7 multiplied with 3 radical 5, we have 21 radical 5. And minus 3 radical 5 times 7 gives us minus 21 radical 5. And minus 3 radical 5 times plus 3 radical 5 gives us minus 45. So let us simplify the given expression. In the numerator we are going to combine the like terms. So 60 minus 35, they both are like terms, so we get it as 25. And 28 radical 5 minus 15 radical 5, we can write it as 28 radical 5 minus 15 radical 5. So we have it as plus 13 radical 5. So plus 13 radical 5 divided by, as you can see, plus 21 radical 5 and minus 21 radical 5 will cancel out each other. So we are left with 49 minus 45, which gives us 4. Now we can split the numerator, giving it independent denominator, and write it as 25 over 4 plus 13 radical 5 over 4. They want us to get the answer in the format a plus b radical 5, where a and b are rational numbers. So let us compare with a plus b radical 5. So by comparison we can see that a represents 25 over 4, which is a rational number, and b can be written as 13 over 4. So these are the values of a and b: 25 divided by 4 and 13 divided by 4. This is how we are supposed to solve the given example using rationalization. Hope you have understood all the steps and you are liking my work. So if you like the videos, like, share and subscribe to my channel, and thank you for watching.